the circuit. So then we find out the voltage drops. So what is the voltage drop is there? VR1, the formula V is equal to I into R, basic formula. Instead of V, we can write as the VR1, VR2, VR3. Instead of R value, we can write as a R1, R2, R3. So first we find out the VR1 value, I into R. So what is the I value is there? I is the 1 into R1 is the 10. So direct 1 into 10 is equals to 10 volts. Next similarly R2 is equal to, so VR2 is equals to I into R2. I is the 1, R2 is the 20. So 1 into 20, that implies the value as a 20 volts. Similarly R3. So VR3 is equals to I into R3. I is the 1, R3 is the 30. So that implies we are getting the value as 30 volts. Means the voltage drops or voltages across three resistors is the 10 volts, 20 volts and 30 volts. So this is a concept we have followed for series connection. So we see the second problem. Resistance of 10, 20 and 30 ohms are connected in series and in parallel to a 240 volt supply. Calculate the supply current. The current in case of parallel connection. So first see about series connection. So how can the series connection is there? 10, 20, 30 is connected in series across 240 volts supply. So the same method will be we have followed. I is equal to V by R. So to determine the R value, they are connected in series. That's why we are using the formula as RT is equal to R1 plus R2 plus R3. That implies instead of R1, R2, R3, we substitute the values of 10, 20, 30. That implies we are getting the value as 60 ohms. Then the supply current is I is equal to V by R. So V is a 240 by 60. 64 just 240. So 0, 0 get cancelled. 64 just also you can do with the calculations. So that implies 4 amperes you are getting as a current when the three resistors are connected in series. But in second case, the three resistors are connected in parallel. So in case of the parallel connection, the voltage is constant, but the current is divided. So to determine the current values, so first we calculate the what is the individual currents. So to find out the total current, first we find out the individual currents. So if you determine the individual currents, they can easily solve the problem. Because I is equal to I1 plus I2 plus I3. That is a basic concept we are using in case of parallel connection. So to find out the I value, the voltage value and resistor value will be sufficient because I is equal to V by R is the formula. V value is given, that is in parallel circuit, voltage is constant, means at I1, I2, I3, V is the 240. R1 value is already given in the problem, that is a 10, 20 and 30. So directly we substitute the values. Then we find out the current values. So where I1 is equals to V by R1, that implies 240 by 10, that is equal to 24 amperes. Similarly I2, V by R2, 240 by 20, 12 just 240, that is equal to, we are getting as a 12 amperes. Next I3 is equals to V by R3, 240 by 30, 38 just 240, that implies we are getting the value as 8 amperes. In parallel circuit, we know that I is equals to I1 plus I2 plus I3. That implies 24 plus 12 plus 8. We are getting the value as 44 amperes. 44 amperes. This is a one method. If you want to find out alternative method, that is also is there. That is equals to first we determine the equivalent resistance. So to find out the equivalent resistance, so the three resistors are connected in parallel. So because of that reason, first we find out the value of equivalent resistance. 1 by RT is equals to 1 by 10 plus 1 by 20 plus 1 by 30. So first we take the LCM. LCM as a 60. So 10, 20, 30. So LCM we can take as a 60 as a common. So that can be helpful for determining the easy calculation. So if you are taking LCM as a 60, so in 10 we are getting the 6 plus 23 just 63 plus 32 just 60. So totally numerator 6 plus 3 plus 2 by 60. That implies 6 plus 3 plus 2 is equals to 11 by 60. So but that is a 1 by R total. But what is our requirement? R total is our requirement. So because of that reason, we are interchanging the portions of numerator and denominator. Means 60 comes to numerator, 11 comes to denominator. So hence R total is equals to 60 by 11 ohms. So to find out the supply current, we know the basic formula I is equal to V by RT. V is the 240. Instead of R by T, we can so RT we can write as a 60 by 11. So 11 in the denominator, so that's why it will become to numerator. So when we are taking the common ratios, so that implies 240 into 11 by 60. So 64 just 240. 64 just 240. So 4 into 11, 44 amperes. So this is another method. So which method you can easily possible? So you can follow that method. So this is for parallel connection. So there are some models is there. Those things will be discussed in the next class. So how the current will be divided. So the same concept. So in this concept also we are using here. The voltage source is connected across two resistors R1 and R2. So the total current is IT. It is divided into two portions, I1 and I2. So already we know the concept. The total current is equals to IT is equals to I1 plus I2. First find out the I1 value. I is equal to V by R1. I2 is equals to V by R2. So therefore V is equal to I into R. So instead of we are taking as I1 R1, I2 and R2 to determine the voltage value. Right? So because the voltage is constant for any resistor across in case of parallel connection. Right? To determine the I1 current, so first we take the opposite current into opposite resistance by total resistance. So that is the formulas will be we are used. So those things will be discussed in the next class. Right, I'm enabling unmute option. If you have any doubts, you can ask. Do you understand the problem?
Sir.
Yes.
First problem name VR1 equal to IR1